Hello everyone. Today we will cover the requirement of engineering materials. So the study of engineering material is connected to material science and metallurgy. And the selection of engineering material is driven by several key requirements which can be categorized into functional requirement, operational requirement, manufacturing requirement and economical requirement. Each plays a critical role in determining the suitability of material for specific application. Let's take the first one, which is a functional requirement. Functional requirement refers to the material's ability to perform its function effectively. This ensures that the material possesses the necessary properties to perform the required task. This include mechanical properties like strength, hardness, ductility, toughness, which basically determines how well the material can withstand forces, deformation, and impact. Physical properties, materials weight, density, thermal conductivity, and electrical conductivity. Similarly, chemical properties uh, like corrosion resistance also plays a key role in ensuring that material is suitable for its specific function. Let's take an example for a material used in electrical application. As the material used in electrical application must have high electrical conductivity, but it should resist the corrosion and it should resist the chemical degradations. Now let's take the second one, operational requirement. Operational requirement basically focuses on how well the material performs under the actual working condition, and this includes durability of the material, ensuring it maintains its properties over time without excessive wear. It must also have temperature resistance, meaning it can withstand high or low temperature without melting, cracking, losing its strength. Materials that experience cyclic loading and prolonged stiffness stress need to have fatigue and creep resistance to prevent failure over time. Additionally, the material should exhibit environmental compatibility, resisting corrosion, weathering, and environmental factors that could reduce its operational lifespan. These factors ensures materials remain functional and safe throughout its service life. Let's take an example, uh, turbine blades in jet engine. Turbine blades in jet engine require materials like superalloys that maintain strength, high temperature, and resist thermal fatigue. Now the third requirement is manufacturing requirement. Manufacturing requirements are crucial for determining how easily and cost effectively a material can be processed and shaped into the desired products. This includes machinability, which refers to the material's ability to be machined using standard manufacturing processes without causing excessive tool wear or defects. Formability is also essential, as the material should be able to undergo shaping processes such as casting, forging, extrusion, or molding without minimal defects. Furthermore, weldability is vital for materials used in structure that requires assembly. They should allow for easy joining through methods like welding, riveting, or adhesives. Finally, availability. Availability of the material in the required form and quantity is important for ensuring efficient manufacturing. Let's take an example for manufacturing requirement is aluminum material used in automotive manufacturing, because uh, due to its lightweight nature and ease of forming, and also ability to be welded or riveted without difficulty. This makes it a practical choice for industry. Now let's come to the fourth requirement, that is economical requirement. Economical requirements are essential in evaluating the cost effectiveness of materials, considering both initial purchase price and long-term performance. This includes material cost. It is a primary factor as the selected material must be affordable while still meeting all the functional and operational specifications. Additionally, the process cost, it must be reasonable. These includes expenses related to shaping, machining, joining, and finishing the material, which should align with the project budget. Now, the life cycle cost is also critical. This includes the total expenses over the material's lifespan, including maintenance, repair, and replacement. Materials that are long-lasting and require minimum maintenance often prove more economical over time. And lastly, recyclability of the material. It can significantly impact cost and reduce environmental effect at the end of the product life. For example, concrete is preferred for its cost effectiveness and low maintenance. Similarly, wood and polypropylene are also used in construction and packaging industry respectively, because wood is affordable, easy to process, and durable with a long lifespan when maintained properly. Similarly, polypropylene is also a low cost, durable, and easy to manufacture, which requires minimum maintenance. So these are the four requirements which are taken into consideration while selecting the engineering material for any application. Now let's talk about the classification of engineering material. Engineering materials are broadly classified into four categories. First one is metal, ceramic, polymers, and composite. Metals, let's talk about metals. Metals are strong, durable, and malleable. They can be divided into ferrous metals, which contains iron element, and the non-ferrous metal, which do not contain iron element. Now ceramics. Ceramics, these metals are basically hard, brittle, and heat resistant. They can be divided into crystalline ceramics, which has a regular atomic structure, and the glasses, which has a disordered atomic structure. Now let's talk about polymers. Polymers, these materials are organic compounds made up of repeating units of molecules. They can be divided into thermoplastic, thermosets, and elastomers. Thermoplastic materials are those materials which get softened when heated and it gets hard when it is cooled. Thermoset materials, basically when heated it's become hard permanently, and the elastomers materials are like a rubber like materials. Now composite material, these materials are made up of two or more different materials combined together to create a new material with improved properties. They can be divided into uh, different types, which is a metal matrix type, ceramic matrix type, polymer matrix type, and there are many other types of composite. So that's it for today. We covered requirements of engineering material and classification of engineering material. Thank you.